In this video, I'm going to go over how to write an equation from a table. While watching the video, it would be helpful if you had the note-taking document that goes along with it. If you do not, that's okay too. You can just copy down the tables and do the work from there. So when you're trying to write an equation from a table, you really go through three main steps. So make sure that you are writing down these three steps, either in a math notebook or on the note-taking document that you have. The first step is to find the slope. In order to find the slope, you are going to find the change in y and put it over the change of x. This was the same thing when we were doing the rise over run. It's really figuring out the same thing. But when we're dealing with a table, how it shows up usually is it's listed as the x and the y. So we're going to be putting the change in the y values, and we're going to put it over the change in the x values. That is the first step. For the second step, you are going to find the y-intercept. The spot that you're going to find the y-intercept on the table is going to be the value of y when x is equal to 0. So you're going to look at the table. Sometimes it's given to you in the table, which is when it's really nice and easy and handy. You are going to be able to look at the table and say, all right, here's the y, here's the x. The x is 0, so the value of y there is my y-intercept. If you aren't given that, we'll talk about what you can do. The third step is you are going to take the information that you know and you are going to write the equation in slope-intercept form. So basically you're just taking what you have from step 1 and step 2 and putting it into our slope-intercept form of y equals mx plus b. Remember that when you are doing y equals mx plus b, we talked about how you are going to put the slope right there for the m, and the y-intercept is going to be the b. Let's look at this first table together. So if you remember the steps, our first step is going to be to find the slope. We are going to find the change of y over the change of x. You may have noticed that when I just wrote that down, I used a triangle and then put a y in a triangle and then an x. This is a shorthand way of saying change in y, change of x. It's something with using, I can't remember, the Greek or the Latin alphabet. It's a symbol for that. So if you see that triangle, all it's saying is that it's going to be the change of y, the change of x. So then I'm going to go to the table. Now the thing you have to make sure you're doing is when I'm doing the change of y, it's on the bottom of the table. So from 5 to 2, the change from there is subtracting 3. From 2 to -1, it's also subtracting 3. From -1 to -4, subtracting 3, subtracting 3. So that's going to be the top of our fraction, -3. In the x, the change of x is going +1, +1, +1, +1. So you can see that the change is constant in both the y and the x. So the change of x is going to go in the denominator, which is 1. And then if you can, you're going to simplify the fraction. So -3 over 1, which is -3. So that is your slope. M is equal to -3. Then we're going to go on to number 2. Remember, 2 is to find the y-intercept. You are going to find the y-intercept where x is 0. So if you're going along the x row up here, you're going to see right here x is equal to 0. So you're going to look at that spot right there in the graph, and you'll see on the graph that where x is 0, we're going to have the y value as our y-intercept. So here's x is 0, the y is -1. So the y, or the y-intercept for this, is at 0, -1. So that means our b is equal to -1. Step 3 is we just put it together. We take what we got in step 1 and step 2 and put it into y equals mx plus b. So I get y equals -3x minus 1. Or I suppose you could have written it as negative 3x plus negative 1. So here's another table. Make sure you're writing these down with me or using the notes, the note-taking sheet so that you can follow along and practice doing this. So on this one does look a tad bit different because it's going vertically versus horizontal. You can be given a table either way. You still do the same steps. So the first one that we're going to do is the first step is to find the slope. So we have the change of y over the change of x. So here the change of y is on the right. So I'm going to look here from 6 to the 8. I go up to 8 to 10, adding 2. 10 to 12, I'm adding 2. So that's going to be a positive 2 on the top. Over here, I have plus 1, and plus 1. So my change of x is 1. So I simplify that, I get 2. So that would mean my m is 2. Now on this one, when you look at the table, you might see how there isn't a spot where x is equal to 0. So sometimes this happens and you have to use the pattern of the table to help you figure it out. So if I'm thinking about the table, I would have to go back 1 to 0, which would be 1 in the tables, or backwards 1 in the table. So I'm gonna go backwards 1, and if I'm going, let's say I'm like subtracted 1 to get back there. When I'm going this direction, I'm adding 1. If I was going the opposite, I'm subtracting 1. The same thing happens over here. If I'm going and adding 2 each time here, if I'm going the opposite direction, I'm gonna have to subtract 2. So that would mean that the y value is 4. So that's going to be what my y-intercept is. The y-intercept is at 0, 4, and so the b value is equal to 4. And then the third step is we're just going to put it all together. So when I put it all together, I'd have my y equals my slope of 2x plus 4. All right, next table we're going to start once again with finding our slope. So we have our change of y over a change of x. So looking at the change of y, it goes from 0 to 6. So this is plus 6, 6 to 12, adding 6, 12 to 18, adding 6. So my change of y is 6. Then I'm going to go over to my x, and I'm going to add 2, add 2, add 2. So my change of x is 2. So simplify 6 over 2, which is going to give you a 3. So my m value is equal to 3. So going back, going into my y-intercept, you can see looking at the x values that I do not have a spot on here that is equal to 0. Now you got to be careful. I know that y is equal to 0 there, but we are looking for where x is equal to 0, so don't get fooled by that. So I know that 0 would be 1 backwards here. Oops. So maybe right up here. So really from 1 to here, I subtracted 1. So this is a little bit different than what the pattern was in the table and how it was given to you, because if you look at it from 1 to the next, it was going from it was adding 2 each time. So if I'm subtracting 1, really that's taking half of this change. So if I'm taking half of the change here, I'm also going to have to take half of the change here. So if I'm adding 6 as I'm going this direction in the table, when I go backwards, I am going to be subtracting, and I have to subtract half of 6, which is minus 3. So 0 minus 3 gets you back to negative 3. So my y-intercept for this would be at 0, negative 3. So my b is negative 3. So now I'm going to put it all together. Y equals my slope of 3. 3x minus 3 is where my y-intercept falls in the table. Next example, you're going to see something a little bit different happen with this one. But once in a while, the data that you have kind of jumps around a little bit. So I want you to be aware of what could happen. So my change of y right here, so change of y over change of x is going to be adding 4. Then I'm adding 6. I'm adding 4 again. And then my last jump is adding 8. So when I do this all, I have different numbers, which sometimes happens. So I had a 4, I had a 6, 6, I had a 4, and I had an 8. I'm just going to put those on the top of my fractions for now. Let's jump up to the x. So here I had a 2, and then I had a 3, I had a 2, and I had a 4. So I'm going to put those same changes that go with changes of y. So like here I had the 4, and the change of x was 2, so 4 over 2. Here I had the 6, my change of y was 3. Here I had another change of 4, my change of y is 2. Here I had a change of 8, and my change of x is 4. So if you look at these fractions that I just wrote, the change of y over the change of x, maybe you'll notice something. I have 4 over 2, 6 over 3, 4 over 2, and 8 over 4. Do you notice anything about those fractions? Maybe something they have in common. Hopefully what you're seeing, that 4 over 2 is equal to 2, 6 over 3 is equal to 2, 4 over 2 is equal to 2, 8 over 4 is also equal to 2. So when I simplify those, they're all equal to 2. So even though it kind of looks like it jumps around really crazy and weird, when I find my change of y over my change of x and I simplify that, I get 2. And that's why it's a linear relationship, because it's increasing by the same amount each time. Basically, for every 2 that the y goes up, the x goes up by 1. So that's why the points would fall in a line. So I have my slope. Then I'm going to go back to my table and see, do I have my y-intercept? And sure enough, right here, x is 0. And I always get super excited when I see that my y-intercept's given to me, because that means I don't need to do any work. It's right there. So my y-intercept is at 0, 2, which means that my b is equal to 2. So when I write my equation, I'd have y equals 2x plus 2. This is going to be the last one we do together, and then I'm going to have you try a few on your own or with a partner if you have somebody to work with. So on this one, same deal, always starting with the change of y over the change of x. So my change of y, 6 to 0 is a minus 6. 0 to negative 6, minus 6. Here I have a minus 3 and a minus 3. Up on top, I have my change of x, which is plus 2, plus 2, plus 1, plus 1. So if I do my change of y over x, I'd have negative 6 over 2. I'd have another negative 6 over 2, a negative 3 over 1, and a negative 3 over 1. So once again, jumps around a little bit, but if I simplify negative 6 over 2 and negative 3 over 1, that's going to give me a simplified number of negative 3 each time. So that's going to be my slope. So now if I look for my y-intercept, I'm looking at my x values, and I'm looking to see, hey, do I have where x is 0? And I don't. So that means I'm going to have to do a little bit of work. So when I am looking, I know that x is going to fall about here, because it'd be right smack dab in between negative 1 and 1. So from negative 1 to 0, it's 1. Same thing from 0 to 1. So I can use this slope here. See how that same change happened here, where it was adding 1. So I'm really going from here to here and adding 1. So when it was adding 1, see how it was subtracting 3. So that's going to mean from here to here, I'm subtracting 3. So I'd go from 0 to -3. And the other thing you can really see when I fill in that middle is really I'm finding the point that's in between -1, 0 and 1, 6. So this is halfway in between -1 and 1. So my value here should be halfway between 0 and -6. So my slope, or not my slope, my y-intercept for this equation is going to be at 0, -3. And that is going to be where b is -3. And I just want to throw out there, it is a coincidence that the last few problems that we've done, I think most of them have had the same y-intercept and the slope. That does not always happen. It is actually quite uncommon. I do not know how I had so many examples that had the same slope and the y-intercept. So when I write this, I'm going to have y equals -3x minus 3 for my equation. So now it's your turn to try. There are 3 problems here, and there's an additional 3 problems on the next slide. So if you have the note-taking sheet, I want you to go ahead and try all 6 of them and try to come up with the equation. So you're going to pause the video. You're going to try it either by yourself or with someone else if they're working with you. And then you're going to turn the video back on to help check your answers. So go ahead, pause the video, and give it a try on your own. So here's what your work should look like for the first few. So you probably noticed that when you went through it, the change of y was the same every time. It was adding 4. The difference was when you went to do the change of x. So that's what gave you a different slope. So you got a slope of 4 here, slope of 1 here, slope of 2 here. Then you can see where I found the y-intercept for each. The third one you did have to do a little bit of work for because it would be halfway between the -1 and the 1. So that's where the 0 is coming from. So then it's also going to be halfway between the 3 and the 7, which is 5. So your final answer should be the equations that I have written in green here. If you haven't done these 3 tables yet, go ahead, stop the video again, try to find the equation for these. If you have already done them, because you did all 6 of them already, go ahead and just keep watching it. Otherwise, pause and give it a try. All right, and the last 3 examples here. A couple things I want to point out. If you look at this first one, the slope was -3. You did have to work back a little bit further than what we have done on the other examples because I had to go back 2 spots. So I still use this pattern. It was going up by 2 in the x's, down by 6 in the y's. So I worked backwards. I worked backwards to 2, and then I worked backwards to 0. And then I also, so if I'm going this direction, I had to add 6 to get me there. So that's how I got the y-intercept of 26. On this one, the y-intercept was way over here on the right, which is a little bit different. And that's how I got the y equals -3x plus 2. And then down here, one thing I want to point out, my slope was 25 over 10. So if you get a fraction like that, you can simplify it and you can actually keep it as 5 over 2. Sometimes I would keep it as a fraction like this. Otherwise, oftentimes you will see it as a decimal too. It kind of depends what the situation is and what sorts of numbers and things you're dealing with. So at this point, I hope you feel comfortable writing an equation from a table.